Hello, everyone. Welcome to the GEC25 Demo Lightning Talks. In this session, the demo presenters will be coming up here and giving a quick overview of their demonstration and get you excited about visiting their demo. The demo is tonight at 5:30 in the gallery downstairs, which is right next to the registration desk. Now, the way we're going to be doing this is basically on the far display, there's a list of the demonstrations that are going to take place, and the presenters are going to come up in the order listed on that slide. So, for example, the College University of New York will be up first, and what you'll see on the main screen is a slide presentation that tells you the demo name, the demo presenters, which university they're from, and where they will be physically in the area for the demonstration. So as we go through the list, if you're the next presenter, please line up at the stairs so we're ready for you to come right up as the current presenter gets done presenting their information. And once you're done presenting, please go see Manu, who will be sitting right there. Okay, go see Manu because he needs your MAC addresses for tonight for some reason. I don't know what. Your yeah. And also, I want to remind you that tonight there will be ballots for the demonstrations. You get to vote for the best demonstration, and there will be prizes based on your votes. Okay, so we can get started. So the first set of presenters is from the City University of New York, and the demo is called Moving Targets Defenses, and you can see where they will be physically located.
So hello everybody. So I'm Ming. I'm from the City University of New York. So our demo tonight will be about our first idea, our initial idea of using moving target defense to mitigate the cyber attack, which is the DDoS in this demo.
Okay, thank you. Careful. Next up is Freda Fund from NYU Poly.
Hello. I'm going to demo the Run My Experiment on GENI blog. It's a repository of ready-to-run GENI experiments on topics like security, networks, network protocols, wireless distributed systems, and others. So if you're in the market for reproducible experiments that you can use in the classroom or to build on in your research, or if you have an experiment of your own that you'd like to share, please come see me.
Next is SDN-based traffic analysis from Clemson University.
Hello. So in today's demo session, our Clemson team will propose a SDN-based traffic analysis resistant network architecture. We call it TOR in short. So the core idea for TOR is basically bind the communication session with dynamic and keep changing IP addresses. So if you're interested in our traffic analysis resistant network architecture, feel free to drop by tonight and we can discuss more about details. Thank you.
It looks like the Oklahoma State folks are not here. They'll be presenting a GENI-based cyber physical testbed for advanced manufacturing experiment. Please stop by and see them. Next, University of South Florida. Okay, also not here. Oh, would you like to come up? No? Okay. Distributed delay minimization approach for network control systems in a wide area power grid. And they're located in the back of the room. Virtual Computer Network Labs, UMass.
I am Bhushan. So we're located right there. So what we have is a virtual computing networks lab We have 2 new additions, one with the network address translation, and we have our initial approach in SDN-based open shortest path first routing. We also will be showcasing an orchestration tool called Jupyter. It's something that you saw earlier today, so if you want to learn a little bit about it, you can just come by. Thank you so much.
Next is the University of Virginia.
Hi, good afternoon, everyone. I'm Saurav. I'm going to be talking about a novel internet access service that basically does online elephant flow redirection. So basically, elephant flows are kind of traffic you generally do not want your commercial network because they can hurt other flows, other traffic. And I'm going to, I have a poster presented and also going to show you a live demo on how we are doing this online traffic engineering and talk about the challenges we faced. Thank you.
Next is Renzi.
Hi, I'm Anirban Mandal from Renzi. Our demonstration is about how domain science applications can leverage GENI technologies and advanced SDN technologies. And what we'll show off in our demo tonight is basically how scientific workflow systems like Pegasus can do data flow prioritization for the large-scale data transfers in the workflow using a virtual software-defined exchange that we instantiate on ExoGENI. So if you're interested in science workflows and how science applications can leverage these advanced GENI capabilities, please come by our booth and see my demo. Thank you.
Next, steroid open flow service.
Hey, my name is Shyam. I'm from Clemson. Our project is a SDN-based solution called Steroids Open Flow Service, or SOS. So this is basically a project which transparently increases your data throughput. How we are doing this, that on the user side, user will just run a simple application. Suppose you want to do a wget, you'll do a wget. But on the back end, we'll be increasing your throughput. We might be using the parallel TCP. So we have a demo set up down there. You are welcome to visit.
Next, Rutgers wireless testbed.
Hello, I'm Mike Sherman from Rutgers. I've got I'm going to call it a programmable wireless edge testbed. It's a portable orbit node running a open source LTE stack, and I'm going to demonstrate connecting a commercial handset to that, and then the core network is currently running in a GENI slice that's tunneled into it.
Next, Northern University of Illinois.
Good afternoon. I'm from Northeastern Illinois University. I'm Graciela, and this is my student, Graciela Warner. And we'll be talking about experiences in which we have used GENI and the Affinity Research Group model, which tries to enhance research in a collaborative approach for minorities in the classroom. So we have developed several labs, very basic labs that try to engage students from unprepared groups or underrepresented minorities. And also we're trying to develop a interactive textbook using clickers and other tools. So please come visit us if you're interested. We'd love to see hear your feedback. And we try to foster deep learning by enjoying learning, challenging learning, and overall making a difference in the classroom with learning. Thank you.
Next, College of Clarkson. Charleston, I'm sorry.
It's okay. It's okay. I'm Mac Knight. I'm an undergrad student at the College of Charleston. It'll actually be just me today, but what my demo will consist of a scalable SDN approach to detecting and mitigating a denial of service attack. This demo is actually based on Dr. Zenia's work on her demo from last year, except this year I'm going to go into more of the implementation details and how you could incorporate it into a classroom. We actually use it at the College of Charleston to teach students about cybersecurity, software-defined networking, and intrusion detection systems. So if that sounds interesting to you, please come by.
Next, University of Missouri.
Hello everyone, my name is Dmitry Chemadanov. Today I will present the demo about computer vision application and how they can be applied for public safety area, how we can benefit, how we can transform them to benefit from cloud for kind of infrastructures. The last thing to note is that this demo won the first prize in the GENI experimenter contest, and it's publicly available and reproducible to some extent. Thank you.
University of Toronto.
Hello, I'm Hadi Banazadeh. In this demo, we will show the work we did to federate Layer 2 with Savvy Networking Canada and GENI through Internet 2, Mail to us, and Starlight. We had quite a few challenges, so we looked at each of these challenges, tried to find a solution, developed a system called HyperExchange. And I would like to invite you to come to my booth and see how we address those challenges. Thank you.
UNC.
Hi, I'm Jay Ikat from UNC Chapel Hill. If you want to look at tutorials, both in terms of instructions for running things on GENI, as well as videos on how they're done, that's one reason to stop by our booth. The other is to look at webinars. So we've been running these series of webinars, both in terms of using GENI in the classroom, as well as having people in the community do a webinar to show some technology or teach some new concept using GENI. And when you see these webinar videos, so we have all videos for these webinars. When you see them, think about what you're doing with GENI, and if you think that you can present at a webinar, we're looking for volunteers. Thank you.
Oh, Clarkson.
Hello, my name is Garagin Grigorian. So we present the Greener Energy Aware SDM platform, which is aimed for efficient usage of green energy that is reproduced at green data centers. At the same time, we want to provide high quality of service for clients. And in our poster, we will show what kind of flows we use, how we install them, and also we will talk about our spec that we developed and how reproducible is our GENI experiment. Thank you.
US Ignite.
So you guys have heard me talk about Planet Ignite. We're going to be running a video that shows adding a node in about 15 minutes. I should have re-screencasted to show U of T with Hadi. But thanks very much. Come by. We're right by the food, so you can pick some up and throw it at me.
Georgia Tech.
Hi there, I'm Sean. Yeah, and we're right by the drinks, so come by, visit us. So we're talking about oh. Right. So SDX, we're talking about two SDX related projects. Metro SDX, which is an evolution of the network, hopefully a good idea for future networks that favor interconnectivity within a community rather than just at exchange points. And the second is an updated demo of the Atlantic Wave SDX controller running on hardware down in Atlanta with much easier to use interfaces. So feel free to come by. We'll have a video running, but if you want to poke and prod, feel free. We do have that available.
Okay, that's it. We'll see you at the demos. And don't forget to vote with the ballots. Thank you.